I now turn to the prevailing empirical findings, and we have already seen for the utility function, the graph is of capital U, by the way. We have already seen utility is prevailingly concave for gains, and for losses, as I already said, it's not what economists think, but the prevailing pattern is convexity in fact. We already discussed it. And then, of course, there's the kink at zero. And here is probability weighting, the prevailing finding for probability weighting functions. The gain weighting function, we already saw it before, it's a black curve. And the blue curve is the prevailing weighting function for losses using the prospective formula, of course. I already told you these curves are quite similar, quite the same, which is the case, but a bit different they are. Usually the weighting function for losses is a bit closer to the diagonal than for gains. So the overweighting of small probability is less pronounced, and the underweighting of big probabilities is also less pronounced. We're a bit closer to expected value. Something of that kind, in fact, also happens for utility, because indeed for losses, utility is prevailing convex, but the convexity that we find for losses is less pronounced than the concavity that we find for gains. For losses, the utility function is closer to linear than it is for gains. So again, we're a bit closer to expected value maximization. This also means, well, we do find reflection in the sense that risk attitude flips. If you go from gains to losses, it flips. But we don't have complete reflection. We have only partial reflection. This is the empirical finding. So the patterns are less pronounced close to expected value for losses than for gains in general. Long time people thought, including me, that this was because losses are problematic for subjects more than gains. Subjects find it difficult to think about, they don't like it so much, they get more confused, you have more noise in the data, and more noise means less pronounced patterns. And in fact, I wrote, you can read it in my 2010 book, I wrote that as the explanation. However, time has proceeded. There have been a few studies by Eldad Yechiam and colleagues. They investigate in data and psychologists and introspection and everything. They find quite different explanations. They say people are in fact paying, subjects in experiment also, they are paying more attention to losses. They are more careful there, they're more thinking. If anything, you have less noise there. But then people also are more rational there. And that could explain why for losses people are closest to expected value. Because I think the rational thing is expected value maximization. So that would be, so that's a new, so you see sometimes the ideas change over time, we learn more and more. Here's one example. Commonly, the empirical patterns, the people use the term fourfold pattern for it. What it means is, imagine we have a lottery with one non-zero outcome. That can be a gain or a loss, and it can have a small or a big probability. Now, so we have four situations that we can look at. In every situation, if you change one of these things, then the risk attitude flips. For instance, let us start with a big probability of a gain, and then usually we find risk aversion there. However, if we change it into a small probability of a gain, then it flips and we find prevailing risk seeking. That's because of the overweighting of the small probability of the good outcome. And that is also a basis of lottery industry, one big factor contributing to why people want to play in lotteries. But if we continue changing, well, we have then a small probability of a gain. If we then change it to a small probability of a loss, then it flips and you get risk aversion. Now, there's still the overweighting of the small probabilities in the blue curve here, but that is now meaning people are overweighting the loss, and that makes them more risk averse. People become risk averse then. Finally, if you have big probability of loss, then people are prevailingly risk seeking again. So that's the fourfold pattern that we find empirically. Now, as regards volatility of the data, in general, the more rational a component of a risk attitude is, or general decision attitude, the more stable the empirical findings. The utility function in prospect theory, you can call it, especially basic, you can call it a rational component, I think so. It's part of expected utility, for instance. And indeed, the empirical measurements of utility are reasonably stable. Now, probability weighting is more irrational. And I, as a Bayesian, think it is irrational, but it still satisfies some basic conditions, stochastic dominance and all these things. So the empirical studies on probability weighting are more unstable. There's more noise, more heterogeneity for probability weighting functions than for utility functions. Things get even worse with loss aversion as we define it, but it's only due to framing, right? Things that should be treated equivalent just because you frame it as gains or losses. That's why people behave very differently. That loss aversion is very irrational. And indeed, the empirical studies and empirical findings of that are very unstable. Sometimes people find very strong way loss aversion 3 or 4, and then you change 2 words in the questionnaire, and then it completely disappears, and you hardly understand why. So loss aversion is a very volatile phenomenon, and it's hard. It may be discouraging when you hear it that you want to study it at all. But I already said it is so strong, we cannot ignore it. I think, as I said before, from the risk aversion that we find empirically, I think more than half of it is due to loss aversion. It's doing a lot. We have to study it. But there have also been many debates. Some people, if they don't find loss aversion in the study, they have criticized it, say we don't think that loss aversion exists. So there are many debates going on. But then, as I said, it's so important. We have to continue our best to understand it as well as possible. If you want to do data fitting, you want to work pragmatically with calculations, with prospect theory, then you make convenient parametric assumptions. And a very common, good working approach is that first, the utility function for gains, usually mostly people assume a power function there. They also call that constant relative risk aversion, but in prospect theory that term is not so nice because risk aversion means something different. But anyway, we take a power function there, and then usually the power is smaller than 1 because utility is concave. Maybe it is a square root function, for instance. Then if you want to be very pragmatic, then it is reasonable to assume that the utility function for losses is like the utility function for gains, but reflected. That means you apply the same power to the losses. And first, maybe you're a bit puzzled. Wait a minute. For negative numbers, the square root is not even defined. So I should be more precise what I mean. What I mean for losses, first you take the absolute value, then you apply the power to it, and then you multiply, you bring back the -1, so you multiply by -1. So that works quite well. And then if the utility function is concave for gains, it is convex for losses, fitting with reflection, and it works quite well. Well, there's utility, maybe I was talking about basic utility. We also have to think about the loss aversion parameter. So that's an extra parameter that we have to do our best. We try to measure good as we can, or otherwise we take the best guess that maybe 1.5 I would recommend right now in general. So then, one parameter for utility, one parameter for loss aversion, and then there's also probability weighting. And for probability weighting, I recommend using a 2-parameter family because the motivational and the cognitive component, they work very differently. They're both strong, and it's good to have them separate. So then you have 4 parameters in total, and life is not so bad with that. You don't need very many data to get reliable estimations of it, and they give quite well empirical performance. One more comment about insurance is a little while ago I said insurance is for losses, and then it's more convex. Like, okay, so if anything, utility is arguing against insurance, going in the opposite direction. So how can we explain insurance? Well, in decision theory, the plausible assumption is the component that explains it is probability weighting. We have, I already said, for small probability losses, we are at that part of the blue curve. These probabilities are overweighted, making people risk averse. That's a big reason why people want to buy insurance. They overestimate the small probability that the house catches fire, for instance, things like that. So now you also see that for insurance, in the behavioral approach, things have completely turned upside down. The story is very different than in classical. Classical approach has concave utility. There are many studies taking third and fourth derivative of utility to capture all kind of aspects of phenomena in insurance. But the behavioral approach says you're barking up the wrong tree. This is not utility. You better look at probability weighting to understand insurance. So you see that many things in the behavioral approach become very different than they were in the classical approach. And I think there are many improvements. So a good thing. I hope also that you've seen now from the last 2 recordings how prospect theory painstakingly does everything to make the model this homeomorph, that everything in the model fits perfectly well with psychological processes, which makes that it is a good empirical theory. And indeed, it's the most popular one for empirical work in decision under risk. I prefer to work with that theory. But here I want to finish my discussion of decision making under risk, and we're going to discuss decision under uncertainty and ambiguity, but that will be in next recordings.